Alright, so I'm looking at the four-wheel drive switch for my '01 GMC Yukon XL K1500 5.3 VIN-T four-wheel drive. Here is what Mitchell shows for the four-wheel drive switch, which is, it's just two pins coming from the transfer case control module. Just 8 volts in and signal back out through these different resistors. So that's what they show. Here is what the GM diagram shows. So we're just looking at this side here. And it would appear that both of these are actually drawn incorrectly. And now I know that because, well, we'll read the service information here in a second, but if you see on this one, they are showing a resistor across these 2 pins here down at the bottom, but they're also showing that these are connected through here. So that should be a closed circuit, no resistance there, if you were to ohm it. This one, they do not show a resistor across those 2. They're just only showing it being a closed circuit when you are depressing one of the switches. And underneath this little pad here are these little, oh, come on, focus. Yep, these little contacts, and there's a little metal, I don't want to pull that back out of here now, but because it's kind of a pain to get back in, but there's a little metal piece in the rubber here that when you depress it, contacts, closes that switch. And let me feed that back in there. All right. Now, if we look at SI, and the code I had on this was a B2725 four-wheel drive light came on while driving. It was not changing modes, just driving down the road. And let's see here. Where do they tell you? Okay. Okay, so the 4 switches are normally open. The transfer case control module supplies 8 volts, and they go through so that voltage goes through a 9.09 thousand ohm resistor in the switch, and that's with the switch no switch is depressed. If they detect a voltage outside of the expected range of 0.5 to 1 volt, or for longer than 5 minutes, one of the switches depressed, then it codes. Looking at, actually there's a service bulletin, which is right here. These are the correct resistance values that should appear in step 4. And this is in the trouble tree as well. But normal is this range right here. So the diagrams can't possibly be correct if this is correct, which I believe it to be because it's a service bulletin. And interesting thing here, so this is pins, let's see, well, it's the, it's these 2. On the 2 connectors, the 2 pins closest to the other connector, if that makes sense there. So the bottom one on the 8-pin connector and the top one on the 4-pin connector right there. This is a Dorman unit, actually, from, where is it? Oh, that's upside down. Looks like 3/30/2009. So it's worked since then, actually. And if I'd known this before, I would have just repaired the original switch. These solder joints. Come on now. Really? Focus. Solder joints don't look great. So, there we go. That's one thing. Wow, well, excuse my cell phone filming here. I can't really get a good shot of that for you. But anyways, we have this hooked up. Wow. Well, let's see here. We have this hooked up through an ohm meter. I just have some adapter leads here to go to the pins, so I don't have to hold anything. and right now nothing is depressed. Look at the resistance there. Now if I flex this board, and we try and do it without pushing any buttons or touching any of these little test pins here, if I flex that board, see how that jumped to a reasonable looking number? There we go, 9.1 thousand. That's just me bending this by pushing my thumb down in the center of it. And if I release, there we go. Now we're almost maxing out the meter here for a second. Now auto 4-wheel drive, 61.7 to 68 ohms. So we'll push the auto 4-wheel drive button, and that interestingly works. Now this top one is, let me set this over here in the frame. So that's the auto 4-wheel drive. Here's the 2 high, which should be 656. Nope, I'm sorry, 1.5 to 1.53 thousand. That's a little high, but it's reasonable-ish. And then here is 4 high, which should be 656 to 670. There we go. You got that. Let's see, I can release it. And then we have 4 low at the bottom, which is 2.32 to 2.37. So 4 low switch down here. Hold that down. And there we have that. And then, not sure if I remember what neutral is. We can look at that real quick. You gotta hold 2 of these buttons to reach neutral. Give me a second to look at that. Alright, so to shift into neutral, you would hold the 2 high and 4 low. So we will go ahead and do that. So that would be bam bam. Oh, and the little rubber pad came out again. Let me fix that. Okay, now, so here is 4 low and 2 high, and that is actually within spec. Last time I pushed them, it was jumping around. But I am going to go ahead and plug this back in temporarily, because the interesting thing is this actually, the 4-wheel drive service light came on once while I was driving, and then when I cycled the ignition, cleared the code, it hasn't come back. But now that I've pulled this out, well, and you can see right now, oh, and then it changed. So I was within spec there for a second. Now it's jumping all over the place. So out of curiosity, I'm going to go plug this back in and just see if it immediately trips a fault, and then we'll go from there. Alright, I've got this switch plugged back in. There's the connectors, which, by the way, to get this out, you just push these little tabs up, top and bottom. You need a thin piece of steel or something to get in there to actually press on it to, well, and I don't have the other piece to show you, but it engages with the tab on the part of the case right there. Just FYI. We'll start this up, see what it does right now. Make sure I'm in park. Yep. Now, oddly enough, I don't know if you can see it, but my 2-wheel drive indicator is illuminated, and I don't see a message on the dash, which is kind of bizarre. Let me try flexing this. So explain that to me now. Let me go ahead and I'm going to measure the voltage drop here just for fun. Alright, so I initially just measured across the solder joints there, but I wanted to go ahead and get this back probe so I could show this. So key off, key on. No warning message. I'm definitely outside of the, I believe it was 0.5 volt to 1 volt range there. And we can go ahead and go ahead and just tangle myself up with all these wires, but we can go ahead and put this in gear just to see if that makes a difference. And still no fault there. That's in gear. And don't think you can see it on the video, but the two-wheel drive high indicator is still lit. Yeah, you can kind of see it, at least from my screen here. But yeah, there's that. I'm a little bit afraid to start pushing buttons on the chance that this won't go back, but we'll push the too high button. If I hold that, 4.8. So very interesting. 7.2. I'm gonna try and flex this and see if that makes any sort of a difference. I'm gonna set the camera down. So initially that was not changing, but when I put it in just the right position, it went from 7.2 to 8 volts. Kind of hard to do while holding this. But yeah, there, I just flexed it again, back to 7 point, and then it jumped. So we do have that jumping around on us there. Interesting, very interesting. Yeah, if I bend it back out that way, we're going to 8 volts. No resistor. So I'm gonna go ahead and hook up the scan tool. I want to see if this is tripping a fault code right now. So we're gonna find that out. All right. So when in doubt, RTFM. I guess I didn't read through this that closely, but it does say right here that the signal voltage is monitored, and if no buttons are pressed and it detects a voltage level outside of the possible range, 0.5 to 1 volt, for longer than 5 minutes, then it will set the DTC. So it doesn't necessarily set a DTC just because it's out of the range initially. So that would explain why I'm not setting a fault right away. And I do have stored here a history code. So I suppose we'll go ahead, and I got a O2 sensor code that keeps tripping, but it actually hasn't turned on in the middle yet. But we'll go ahead and clear this. Alright, let's just make sure it didn't leave a, nope, nothing there. So let's go ahead and then just unplug that, and we'll let this run. And I just want to come back in 5 minutes and just see if the light's on, see if we have a code retripped. All right, we're just about to hit the 5-minute mark. Now we're at 7.48 volts, but we'll be within the next 30 seconds here. And there we go, service 4-wheel drive. So they didn't lie. All right, we'll move onward here. All right, I just realized the really obvious error that I made. I was measuring the voltage drop instead of my return voltage, the reference voltage, going back to the transfer case control module. So from ground to the return pin, or the signal pin, well, not open circuit, but the no buttons pushed voltage is 0.27. And if I push the button for two-wheel high, I get 3 volts. So yeah, I'll leave that mistake in there. Alright, so still reference to chassis ground here, just through the pin 4 of the DLC there. I did manage to flex this and get it to read within spec, the half to 1 volt 793, and if I mess with it again, you can see it does jump around. Make sure it's not my back probe falling out. Hang on. Alright, so before I do anything else, because there is no way to easily disassemble this, I'm not quite sure exactly how they do this, but the pins are like in the plastic. They're not removable. I can't get a shot of it right now, but you can't just pull this board out. It looked like it was just retained by these clips, but it does not come out of there without desoldering all of those pins, which I'm definitely not going to do. But before I do anything else, I'm going to set up the soldering iron and just reflow these, and we'll recheck it before we go any further, which in this case I think we have to be replacing the switch, or we could try to cut a hole in the back side of this. I can see the board through the holes and get access to it, and then, you know, it's my car, so if I put tape over it and throw it back in, I don't really care, and it's not going to hurt anything, so we'll see. Before I forget, I should also mention that I did confirm we had 8 volts coming in, and that was with this all hooked up, everything plugged in. I can show you, that's our 8 volt output from the transfer case control module. And it's 8 volts, and it's 8 volts with the switch plugged in and everything hooked up the way it should be. Alright, so I touched this up. I'm just letting it cool down here. On the 2 important pins, I went ahead and solder sucked them, and then used some leaded 6040 rosin core solder to fill in, make sure I got a good joint there. The others, I just put some solder, good solder on my tip, and I just reflowed all of them, making sure to get good contact with the pad and the pin. Not super concerned about those. Want to make sure my 2 control the 4-wheel drive shifting are good though. One thing I will throw in there, by no means am I a professional. I'm using a $30 eBay soldering iron, but I have a whole bunch of tips here. This particular one actually will take the Heiko tips. It's a clone of an old line production Heiko, but always use, especially on this, use enough heat to get in and out quick so you're not heating up the board. And I don't just go down the line when I do this. I do one, then I'll do one on the other end, and then I'll do one on the other connector. Give it some time in between. Make sure that I give time for my iron to heat back up after I've, you know, just put my heat into what I'm soldering. And always use the tip, use an appropriate tip. Don't use too big of a tip, but use one with the most thermal mass that you can, because you won't have to hold it on there as long. You got a better chance of getting a good joint. I really like this style, and I can't get it to focus here. There you go. I really like this style. Big tip, but you know, you got a fine end on it so that you can get in here. And the way that I do it with this style, well, it's not going to focus, is it? Well, you go in here with the wedge pointed down like this, and yeah, there you go. Set it up against that joint like that. Works really well. You get into tighter places than you would think without, you know, flowing solder across 2 joints that you don't want to. So I'm sure some people have other opinions on it, but just want to throw that in there because that helped me a lot. So it is appearing as if I have a broken trace on the board. If I flex this board at all, I got a problem. I let go. Sometimes it goes back to where it should be. Other times I have super high resistance. If I just bend it that way, hold it there, inspect, release it, I'm out. Initially I thought it might be the actual joint still, because I would wiggle my connector and it would happen. But then I realized it would happen with either one. I even tried a different set of leads, and I measured it from up here and it would do the same thing. So I think just from vibration flexing, I have a broken trace somewhere. I don't know that I'm going to be able to access it because I don't know if I can get to that part of the board. If it's broken right up here by the connector, then there's really no access without removing the whole thing. If it's down here somewhere, then it might be accessible. Just flexing that. Already been resoldered. Alright, so decided to take the minimalist approach to open heart surgery here. And I went ahead and cut this open, but just left all of the standoffs here that hold this board on here and this center brace in place for now. And it looks like crap in here. I'm not sure if I'm going to be able to follow this circuit or not, but I might be able to just find the correct set of resistors based on the resistance. I'm going to look around and then I'll update. Alright, I opened this up a bit more to make it easier to get access to everything and easier to see. And if it'll focus, wow. So, we get a pointing implement. That is the resistor in question that's supposed to be always in this circuit, even if the buttons are not pressed. You can see this is actually our terminal right here. There's a test point, and then you follow the trace over, and then you can actually see two resistors that are placed into that. This comes down to here. It's working right now. Now that I have it apart, it measures perfect. This looks absolutely horribly crusty and can't focus. So I don't think I'm gonna get out the hot air gun. I think for now I'm just going to get a small soldering tip and just try and reflow that one resistor, and then just plug this back in, see if it codes again. Alright, so changed my mind. Couldn't stand to look at these solder joints, so put down some flux and just touched all these with a little skinny tip here. Just everything. So I've now reflowed everything on the board. Doesn't look awesome, but it looks much better than it did. And I cleaned off all the corrosion that was on the surface here. I just rechecked with the ohmmeter, and all of the modes are now in spec as far as resistance. They're within the range given, including neutral, and I cannot make it fail. I cannot make it go out by flexing the board. And here are those numbers again for anyone who might need them. And I'm going to go ahead and just tape this up and clean up where I've kind of scuffed this up. We'll put this back in the vehicle. Alright, just ran that for 5 minutes and there's no warning message. And everything works.